So let's take a look at an example. Let's find the radian measure of angle theta between two vectors, vector 1, -1, -3, and vector 1, 1, 1. So we know that the dot product of two angles is equal to the product of the norms of those vectors. Sorry, the dot product between two vectors is the product of the norms of those vectors times cosine of the interior angle between them. So it's this theta that we want, okay? So I'm going to need to take the dot product of the two vectors. I'm also going to need the norms of the two vectors, all right? So let's call this one U. Let's call this one V, just so we have a name for him. Okay. So let's start by finding cosine of theta. So if I divide by norm U and norm V, then I'm going to take the dot product of U and V and then divide by norm of U and norm of V. And I want to emphasize that I can divide by these, right? You cannot divide by a vector, but these aren't vectors. These are the norms of vectors. These are the lengths of vectors. And the length of a vector is just a plain number. I can divide by numbers, no problem. Okay? Okay. So let's start by taking the dot product. So U dot V. So that's going to be first component times first component plus second component times second component plus third component times third component and the norm of U is going to be the sum of the squares of the components, and I take the square root of that. So square root of 1 squared plus -1 squared plus -3 squared. It's going to give me norm of U. And norm of V is 1 squared plus 1 squared plus 1 squared under a square root. Okay, so if I do the calculations, in the numerator, I get 1 plus -1, that's 0, plus -3 is -3. And in the denominator, I get 1 squared plus -1 squared, that's 2, plus -3 squared, that's 9, plus 2 is 11, so square root of 11. And square root of 1 squared plus 1 squared plus 1 squared, that's square root of 3. Square root times the square root, I can multiply the insides. So I get -3 over square root of 33. Okay, now that's cosine of the angle, but I don't want cosine of the angle, I want the angle. So I need to uncosine this. So that'd be arc cosine, right? Now, normally you have to be really careful taking an arc cosine because a cosine function it's not a one-to-one function, it doesn't have a true inverse. The arc cosine function is only good if the angle is between 0 and pi, if it's between 0 degrees and 180 degrees. In this case, that's exactly what we want. The biggest two angles could be apart, or two vectors could be apart, is 180 degrees. Okay, most of the time, they will be less than 180 degrees. So arc cosine only is good if we want an angle between 0 and 180 degrees. Otherwise, we'll have to do some adjustments. But in this case, that's exactly what we want. We want an angle between 0 and 180 degrees. So all I need to do to find theta is take the arc cosine of both sides. And that's my answer. That is the angle between the two vectors.